Hi everybody, welcome to the last review before the final exam. Today we just do a lot of prompts, so you will not see the list above. We just do some prompts, and on that side we still have some formula, not all of the formulas, but some of the new formula. Right, I just will right into it. So first, the average value function, average values of a function. Given by this formula. So we go from -2 to 5. So the first one is A, the second one is B. So 1 over 5 minus -2. And the function is 2 minus x squared. So that will be 1 over 7. Right. 1 over 7. 2 minus x squared. The integral of 2 will be 2x. And the integral of x squared is x cubed over 3. And we go from -2 to 5. And of course we're going to put 5 in for x and -2 in for x. Alright, so 1 over 7, 2 times 5 minus 5 cubed over 3 minus 1 over 7. 2 times -2 minus -2 cubed over 3. Right, so pretty much we put 5 and -2 in it, evaluate and then subtract. We use the calculator for that. Right, let's move that over here. Right. So we have 1 over 7 times, right, since we're going to put 5 and -2 in it, so it's better just store 5 into x, and then we'll just enter the function, pretty much this, 1 over 7 times 2x minus x cubed over 3 fraction -95 over 27. I mean 21. And then we put -2 and then store into x. And we just go up to the function. When we hit enter, just like copy and paste. And then we change the fraction. So pretty much we just do this. So -95 plus 4 will be -91. Wait. Right, 91 divided by 7. So we just, again, If on the calculator we just do this, that copy and paste and then subtract, then we'll all up, copy and paste, negative 13 and 3. Of course you can put the whole thing in the calculator as well. So if we want to check, we can do this fraction 1 over 7 math, go down to integral. That better. Negative 2 to 5 x squared right. So that average values of a function will be this formula, this formula, and we just do the integral pretty much. Right, now we do a lot of substitution in the integral. Right, let's look at this one. So for this one, we will let x to the 6 plus 4 be u. And then we'll take derivative. And move the dx over. And divide by 6x to the 5th. So we need two important things. Dx and then u. So u and dx. And then we do the substitution. X to the 5th still there. Square root still there. And then that is going to be u. And dx is du over 6x to the 5th. Right. Now we see that x to the 5th cancel out. And we'll take the 6 outside. But still below the denominator. Right. And now we just have square root of u. Everything cancel at the bottom. So just du like that. And 1 over 6. I think that's better. 1 over 6. Square root of u is u to the 1/2. And then du. So 1 over 6. U to the 3/2. And then 3/2. Plus c. Divide by 3/2 is multiply reciprocal. And that gives us 1 over 9 u to the 3/2 plus c, or 1 over 9 u is x to the 6 plus 4 to the 3/2 plus c. So that so it was 1 and 2. Right. The rest of this is pretty much the same, right? On this one before, number 3 before we do that, we'll rewrite this as x over 7x squared plus 3 to the 5th, and the dx I move to the side like this. Right, and then the substitution will be the same. So we have u equal to 7x squared plus 3 du over dx, the derivative, 14x, and move the dx over, and finally we will have dx equal to du over 14x, and that is dx. No, not equal to. Now we put everything in it. X on the top still the same. Just divide this. The bottom will be u. We still have the 5th power. Dx is du over 14x. Right. X and x cancel out. The 14 will be outside but at the bottom. And we'll just have 1 on the top, u to the 5th du, and that will give us 1 over 14. U to the 5th is, 1 over u to the 5th is u to the negative 5 du. Integral will be u to the negative 4 over negative 4 plus c. Multiply straight across, we have 1 over 56. Let's just put the negative on the top, and then u to the negative 4 plus c. And finally u is 7x squared plus 3. And that is that. Sorry, that was 3. Right. Of course, we forgot the negative 4 here. Sorry. The next one will be similar, but just let u equal to x minus 2 and do the same thing. Right, not going to do that. Right, try this instead. Right, for this one, let this be u. The reason we let this be u because when we take derivative of this, we have negative sign. Potentially we cancel with this sign, so that is looks like we're on the right track. So take derivative. It will be negative sine t. Move the dt. And divide by the negative sine t. So that is du. Now the substitution, sine t is still there. This is going to be u to the 4th power. Dt is du over negative sine t. The sine t cancel with sine t. The negative sign here still bring in front of the integral. So we will have negative 1 over u to the 4th du and I will just integrate, increase the power by 1, divide by the same thing. Right, divide by negative 3 is multiplied by 1/3, so pretty much we have 1 over 3, negative and negative, cancel out, u to the negative 3 plus c, and then finally we substitute back in for u, and that will be it. U 5 plus cosine t negative 3 plus c. We can move this to the bottom, but that's not necessary. Right. So that pretty much, actually there will be a few more integral. I should keep the integral instead. Right. And nothing new here. Right. Now we go to integral, definite integral, right, with the limits, but with the substitution as well. Right. For this one, let x plus 4 be u. U equal to x plus 4. Right. I'll take derivative of this is going to be 1. Move the dx over, we have du equal to dx. Little thing here, on this problem we will have originally is x equal to 0 to x equal to 1. X equal to 1. Now we're going to make the substitution x equal to 0 and then x equal to 1. When x equal to 0, u is x plus 4, so u equal to 0 plus 4 is 4. X equal to 1, u equal to 1 plus 4, so it will be 5. And the integral equal to instead of x go from 0 to 1, now we have u equal to 4 to u equal to 5. Square root still there. X plus 4 is u and dx is just du. So problem turn into just that. So now we just go from 4 to 5. U to the 1/2 to the 1/2 du. So will be u to the 3/2 over 3/2. That goes from 4 to 5. Notice that those are the values for u, so we do not need to substitute back in for x. So we're just going to rewrite this as 2/3 u to the 3/2 4 5. And we'll put 5 in here and then put 4 in there. So 2/3 5 to the 3/2 minus 2/3 4 to the 3/2. This doesn't do anything because square root of 5 doesn't simplify much. So actually we just keep it like that. That's perfectly fine there. 4 to the 3 half is going to be 4 to the 1 half is 2, so it's 8. 4 to the 3 half is 8, and so that's 16 over 3. Yeah, we just leave it like that. I mean, like this. Of course, this you can write like 5 square root of 5 or 10 square root of 5, but that's okay. I mean, that's good enough. And that is 6. Now 7. Pretty much the same thing here. Let's just rewrite this problem a little bit easier to evaluate. So instead of write cosine square, we write cosine square like this. So we can let cosine be u. And then take derivative. And that will potentially cancel with this sin x, which is good. Right. Move the dx. And divide by the negative sin x. So that integral equal to, so we have everything except we forgot to change the limit. X go from pi over 3 to 2 pi, so I just write here x equal to pi over 3, and u is cosine x, cosine pi over 3, and x equal to 2 pi, u equal to cosine of 2 pi. Cosine of 2 pi is just like 0, cosine of 0 is 1. Cosine pi over 3, sorry, pi over 3, so it's 1/2. Right, so we go from pi over 3 to 2 pi, go to u equal to 1/2 to u equal to 1. We have 3 u square, sine x is still there, dx is du over negative sine x. Sine x cancel out, and we will have the 3 on the top. I move that outside, the minus as well on the outside. So 3 and minus 1 in front of the integral. And nothing at the bottom here. We go from 1/2 to 1. And then we just have u square du. Integral of that will be u cubed over 3. That goes from 1/2 to 1. Right. Conveniently this cancel out, so we just have negative u cubed go from 1/2 to 1, so we have negative 1 cubed So that's where we put 1 in, and then we're going to put 1/2 in. So that's still -1. 1/2 is cube is 1/8 minus a negative. So we have -7/8. Right. So sometimes we have to rewrite, and we do the substitution. We change the limit to u. So at the end we do not need to go back for x because those are the values for u. Right. We're going to do 8 a little bit later. I'll just keep on the integral, so we'll go to 14. Right. Once again, for this problem, I will write the dx on the side, so it's easier to work with. And we start with u, substitution. And we take derivative. Move the dx over and divide by -2. And that gives us dx. Right, we need the integral. Right. Yeah, just like the substitution we did earlier, except this time we have different derivative or integration. Right, so pretty much just that, where we substitute everything in to the integral. Now nothing cancel here. The 5 is on the top, the -2 at the bottom. So we'll have 5 on the top, -2 at the bottom. And we just have 1 over u du. Integral on that side, integral 1 over u is going to be equal to, this is -5/2. 1 over u integral is ln of absolute values of u. And u is 1 minus 2x. So we just like that. Right. Let's look at 15 as well. 15. 15, we're going to let u equal to -x⁻⁷. Because the derivative of x⁻⁷ is 7, some x⁻⁶. x⁻⁶ will cancel with this. And then we'll take derivative. Move the dx. And divide by the -76x squared. (76x⁶), sorry. and then dx. Then the integral equal to x to the 6, e is still there, the negative x to the 7, that is u, dx is this, x to the 6 cancel out, which is good because now we only have u. But before that, let's move the negative 7, the constant, outside of the integral. Then we just have that. The formula is still on that side. So we have negative 1 over 7, e to the u is still e to the u. And u is negative x to the 7. And then we just have that. Right. Right. 16. Right, there are a few options here. We can either let u equal to secant for x, or on the exponent 5 sine of 4x. I will just keep this in mind. If we let u equal to secant, derivative of secant is secant and tangent. Secant and tangent doesn't look like we'll cancel with this. Now, if we let u equal to sine x here, when we take the derivative of sine is cosine, potentially it might cancel with this. So let's start with that. Let's try the exponent. Alright, we'll take derivative. It's going to be 5 cosine 4x. And then the chain rule, if we put the box around 4x, we have to have 4. So, like sine of the box, and then the box is 4x. Derivative is 4. So that's the chain rule. Move the dx over, we have du over 20 cosine x, cosine 4x dx, and divide by the dx over. So divide by the 20 cosine 4x equal to dx. Right, so that is good. So 5 of sine 4x, that is u, and secant x is still here, and dx is this. Right. Cosine secant, actually that cancel out, but we'll do that in a little bit. Take care of the constant first. 5 and 20 be 5 over 20 e to the u secant of 4x. Then we just have 1 over cosine 4x, and I will write du on the side just like I did earlier. That will be 1 over 4 e to the u secant 4x. 1 over cosine is actually also secant, and now we see that they indeed cancel out because we're supposed to have that. We're not supposed to have x left for the substitution, and we just reduce nicely to that. Integral of e to the u is still the same. That will be it. E to the 5 sine 4x plus c. Right. Next, let's do 1 of 17 or 18. Let's look at 17. Right. Let u equal to this. See what happens. Derivative is e to the t is the same thing. Move the dt over and divide by e to the t. Now, t equal to 0, u equal to 5 plus e to the 0, which is 1, so it's going to be 6. And t equal to 1, u equal to 5 plus e to the first power is still e, so we have just 5 plus e, and that's as much as we can simplify. Alright, so that integral we go from 0 to 1. Those are the the t values. Now we go to u, go from 6 to 5 plus e. E to the t is still there. 5 plus e to the t is u. We still have the square. Right. Du over e to the t is dt. Which cancel out. Oops. And there's nothing outside of the integral. Right. We have 1 over u square du. And we have that. So we're going to have u to the negative 1, increase the power by 1, and divided by the same thing as the power, which is negative 1. So that's just the power rule. Unless, of course, the power is negative 1, then we have to use the ln. Goes from 6 to 5 plus e. This is just u to the negative 1. Negative u to the negative 1 goes from 6 to 5 plus e. So negative 5 plus e to the negative 1. That is the first one. And then minus negative. And then we're going to put 6 in it. So simplify this, we have 6 to the negative 1, or 1 over 6. And then minus 5 plus e to the negative 1. So it's going to be that. Next, we're not going to do this, but u is going to be equal to cosine t. And I'll let you finish the problem. Make sure we change the limit. Right. So that's all the integral in this review. Now we do the derivative. We do number 8 a little bit later. Now we do the derivative. Derivative, there will be exponential rule and logarithmic rule, so those rules over there. So check the derivative of this. Because we can use the chain rule. I'll do it 2 different ways. First, the chain rule. We put this into the box. We have ln of the box. And the box is 2x squared. Derivative of what ln of u is 1 over u. And then derivative of 2x squared is 4x. So we have 1 over u 2x squared and times 4x. So we have 4x over 2x squared. Cancel out to 2 over x. So that is one way to do it. This is another way to do it. Y equal to ln of 2x squared. We use this property. Use log of a product is the sum of the log. And we can take the square outside. So that is the function. So the derivative, ln of 2 is a constant. Derivative of a constant is 0. That is a constant, so 0. Derivative of ln of x is 1 over x. And we still have 2 in front of it. So that's just 2 over x. Either way, we get the same thing. Next, we do this. So even though we can use the quotient rule, but that seems like a lot of work. So instead, we use something similar to this, properties of the log. But this time it is dividing, which turns to a difference. I will write that as x to the 1/2 minus ln of x to the 4th. We can take the 4th outside. Notice that ln of the sum, we cannot do anything with the sum here. So that is far we simplify this. And then we use the chain rule. So this is the box. So ln of the box. And the box is 1 plus x to the 1/2. So derivative of ln of u is 1 over u times the derivative of this is 1/2 x to the negative 1/2. And then derivative of ln of x is just 1 over x. So we have minus 4, 1 over x. Now when we clear this out, we have multiply everything on the top. We have x to the negative 1/2 on the top. The bottom 2u. So be 4 over x for that. Right. Substitute back in for u, and I think that will be enough. Not much we can simplify from here. Right, just leave it like that. So that is derivative of the log, natural log. Now we have derivative of exponential function. So derivative of ln of x, I should write that somewhere. And derivative of e to the x is the same thing as e to the x. Alright. So we take the derivative of this. We use the little chain rule here. Negative 8 e to the box, where the box is 3x. E to the u, still e to the u, with a negative 8 in front. The derivative of 3x is 3. So negative 24 e to the u, or negative 24 e to the 3x. So just have that. Right, so e to the x. This is a product rule. Right. Here we can use the chain rule if we like. So v prime is e to the negative x, negative 1 equal negative e to the negative x. So be just that. And then the product rule. U prime ax v e to negative x u v prime minus and a negative, minus a negative turn into a plus. And usually when we have this, both of them have e to the x, negative x in common. I will factor it out. You can also factor out the 4x, but usually that will be enough. So we just that. The next one we're going to use this square root of t. So we have 2 to the box, and then the box is t to the 1/2. and then we take the derivative of that. I'll let you finish that problem. And finally, we go to the inverse function theorem, or derivative of an inverse function, right? Which is 8 and 19 and 20. Right. So on the formula, we will not have any special formula for this because it's better we just derive that from scratch. So properties of the inverse function: the function composed with the inverse give us back x. The inverse composed with the function is also x. Right. So we have that first. So we're going to write, either one of them. But since f of x is like this, so just take the inverse in front of it. So we take the inverse on both sides pretty much. Notice that this with the inverse of the function will turn back into x. Right. Now what we're going to do is we take the derivative on both sides using the chain rule. So put this in the box. So we have f inverse of the box, where the box is equal to the function and then we'll take the derivative. So we're going to have let that be u, or we can just use y, also work. So we have derivative of this. Since we don't know what is the function, we're just going to write like that, and time derivative of this will be 5 times 1024 512, 5120. X to the 4th. Derivative of x on this side is going to be 1. So we're just going to divide this on both sides. So we're going to have inverse derivative of the inverse of y is equal to 1 over 5120 x to the 4th. So it's almost there, except we have x to the 4th. And this is y and this is x. We're going to need to turn that x into a y. So originally f of x, let that be y. So we divide by, we solve for x, so we divide by the 1024 y over 1024, and then we take the 5th root, so going to be to the 1/5, and 1024 to the 1/5 is 4, so we just have y to the 1/5 over 4, pretty much that is x, and we substitute into this x. We have y to the 4 over 5 and divide by 4 to the 4th power will be 256, and 5120 divided by 256 is 20, so I have 20 y to the 4/5. So I have inverse of y, derivative of that is that. Of course, you can write that as x and x here as well, but so we can take the inverse on both sides to cancel the function, turn it to x, take the derivative both sides, and then solve for that. At the end, if this is the function of y, we should have y. Right. So that is the inverse function theorem. We don't really need to use that theorem, just definition of the inverse function. Right. The last two questions of the review is very important. We're going to use also similar to that. So, right. Right. So first, we have tangent inverse is that. Notice that if we take the inverse of the tangent inverse, which is just the tangent, and tangent inverse is cancel out, give you 4 over 5x. I'm going to write like that instead. Now we take derivative on both sides. Notice that y is a function of x, so we have like this, tangent of the box, where the box is y equal to tangent inverse for x over 5. Right. So that is the left hand side. Right. Derivative of tangent. We take derivative of tangent is secant square, and derivative of this is unknown, I mean to be determined. Derivative of this is just 4 over 5. Right. We still have the derivative of this, which we don't know what it is, so just leave it like that. So take derivative both sides, we have that. Derivative of tangent y is this. Derivative of 4 over 5x is this. Now we just, the question asks us the derivative of this, so we're going to keep the term here. And divide by the secant square here. Like that. Now we just need to simplify. The secant square, the secant is, secant. We should write like that, or 5 secant of y is secant of tangent inverse for x over 5 square. I just need to identify what is that, and then we're done. Right, now that is a simple trigonometry problem. So let's do that here. Right, we have y equal to tangent inverse for x over 5. If we take the tangent on both sides, that gives us for x over 5. And the question asks, so The question asks us what is secant of y. Actually, we don't even need to write this. Right, now our tangent of y is that, so we're going to put in the right triangle. Angle is y. Tangent is opposite over adjacent. So this hypotenuse will be 5 square plus 4x square will be 25 plus 16x square. We don't even need this. So will be 4 over 5 secant of y. Secant is reciprocal of cosine. Cosine is adjacent hypotenuse, so this is hypotenuse over adjacent. So will be square root of 25 plus 16 x squared over 5. So that is secant y, and we substitute in here. So that will be 4, 5 square, and the square root be 25 plus 16x squared, and then 5 square 25. 5 and 25 cancel, so that is just divided by 5. Divided by 5 is multiply 1/5. Actually, we just do that. So we have 20 over 25 plus 16x squared. So to recap, to get rid of the tangent inverse, we take the tangent on both sides, and then we take derivative both sides of this, and then we will have that by the chain rule. Solving for that term, divide by what's left, and then we just simplify the rest of the problem. So that was 19. Let's look at 20 as well. So once again, we will take the inverse on both sides. I mean the cosine, just the cosine, sorry. So cosine and cosine inverse cancel out. We just have 9x. Right. Now, we take derivative first, and then we solve for y a bit later. Cosine of y, so we have cosine of y, the box is y, which is that. We take derivative of cosine is sine. Derivative of that, we don't know what it is, but let's just write like that. And essentially that is what the question asks us to find, the derivative, this derivative. Right, on the right hand side, that will give us just 18x. And finally, this derivative will be equal to 18x over sine y. Yeah, we don't need to substitute back the inverse and all that. So this is identical to the problem, and we want to find the derivative of that. Now we just need to find out what is sine of y equal to. So that is like the trick, the triangle like we did before. So we have this problem. And we take the cosine on both sides. Cosine y equal to 9x squared plus 2. And we draw a triangle. Cosine is adjacent over hypotenuse. And then the question asks us what is sine y. So if this is 1 and 9x squared plus 1, so this will be the adjacent. I'm sorry. Cosine is adjacent, so this will be 9x squared plus 2. Yeah, that is 9x squared plus 2 is the adjacent to y. Right, the opposite will be equal to square root of 1 square, which is 1, minus 9x squared plus 2 squared. So that is opposite, and the sign is opposite over hypotenuse. So pretty much just 1 minus 9x squared plus 2 squared. Right. So y equal to cosine inverse cosine of y. Like take the cosine both sides, we have this. Cosine is adjacent over hypotenuse. Find out the opposite, and then we have the sine. And finally, sine is just that, and we substitute in here. So as you see, we do not have any formula for, there is a formula for cosine inverse, but we don't need to memorize that. We also don't need to memorize the formula for the inverse function theorem. All we do is the function and the inverse we cancel out, give us that. Take derivative both sides, and then we can find the derivative of the inverse like that. A little trick here. We have to find sine for y, just like we have to find the secant y earlier. So I think this is very important, and you might see something like this on the test. Right, I think we cover most of the review, and I hope that will help you prepare for the final. The final is on Wednesday. I will not be there. If you have any question, just send me an email, because I'm not going to be in class for the remaining of the semester. So good luck on your final, and thanks for watching.